So hello everyone, I'm Athul from Nokia. I was also the technical manager of the 5G-Xcast project, which then is kind of the link to the broadcast community. So today there are two parts of the talk that I've made. So the first part is about 5G, what's it about? So it's mostly, it'll be focusing on the boring facts side of things. I'll talk a bit about the 5G-Xcast and the 5G broadcast side of things as well. So what kind of value proposition does 5G offer to you, all of you who are mainly from the broadcast community? And in the end, I'll talk a bit about the fiction part of 5G as well. All right, so I don't know how many of you here know, but the cellular networks that we have today, that all of your smartphones have been connected to, it was actually defined in the 1940s by some of my colleagues or in what is Nokia Bell Labs today. So I took a screenshot of one internal technical report that was written by D.H. Ring and was sent to some of his colleagues in Bell Labs, essentially defining cellular networks. And as we know, technology evolves quite fast, and it's extremely rare that something survives for 70 years. But cellular networks have managed to somehow survive for quite some time. But in 5G, we really need to look at this really hard question that is it really time for change? Should we stop calling our mobile phones cellular phones and move on to this next era of connectivity? So what exactly is this next era of connectivity? So I think most of you have seen the triangles here. 5G is essentially three things. So whenever I talk to my marketing colleagues or sales colleagues, they always say that I need to say that there are three things about anything, because three things are mainly what people always remember. If there is more than three, then they don't remember. So 5G is just three things. It's extreme mobile broadband, which basically brings you more than 10 gigabits per second to your smartphones. It brings more than 100 Mbps essentially everywhere within the network. There is a lot of regulation, for example, coming in the EU, which then limits even the minimum capacity or the data rates that the user should get even in rural areas. So 5G is going to kind of dynamically redefine what is connectivity, especially wireless connectivity. It can support more than 10,000 times the traffic. It can also support 10 to 100 times more devices. So if you have typically, let's say, a few hundred devices which is connected to one cell, it would be several thousands or even several millions of devices that could connect to one cell. So the 5G physical layer is robust and flexible enough to support a large number of devices to be connected to the network. 5G is also about extremely long battery life. So with how the physical layer has been defined in terms of how robust it is, it can support devices which requires extremely low battery usage, which then enables this 10 years of battery life that's not possible today, especially with mobile networks. 5G is also about ultra reliability, especially with the critical communication. So several years ago, when the 5G vision was being set up, and then we tried to define what kind of technology enablers are there. So as we all know, the traditional way of how the business models were for the traditional mobile networks, that's being disrupted because that's kind of hitting the plateau where basically operators cannot sell more SIM cards. So you need to find new growth areas. And 5G, or the researchers who were kind of the pioneers in 5G, decided to have a bold vision where basically they decided that they would design a system which could essentially connect any device on Earth, support basically almost any requirement that you might have. And this essentially would require 5G to support even the reliability and latency that is today provided by wired networks. And this is kind of the underlying reason behind the three triangles. And the third triangle is kind of the most disruptive aspect of 5G, which is ultra reliability and low latency. So it's going to be, the latency is going to be less than 1 millisecond, or it already supports that with the release 15 standards or with the enhancements of that. And it should be able to support ultra reliability, which basically means that you get a reliability in terms of packet loss rates and all of 99.9999%. And it enables a lot of other use cases which were discussed today, like the haptic internet. Now I explain a bit what 5G means for Nokia. We call this the future X network. And here X could be basically anything. So you can adapt the network to provide basically any service that you would like to enable with that network. And if you look at how 3GPP has then taken this forward, you can see that the 5G network is essentially quite compliant with our future X vision. So traditionally, mobile networks, the key component has been this the massive scale access part. And that has been the most valuable as well, and that remains the same. But 5G is going to be a lot more. So it would be about a lot of open APIs, which would enable external networks to interwork with the 5G network. So a lot of things that were discussed today, like how do you get the user feedback, or a lot of the user experiences that the user experiences today. How do you get it back to the content provider? Because these are all valuable data. So 5G would be providing, and it already provides a lot of open APIs like the network exposure function, which enables the content providers to get very minute information in terms of, for example, under mobility conditions, what kind of user experience is the user getting for some particular video, what kind of packet loss rates are experienced in, let's say, one crossover in some city, and actually this gives a lot of valuable insights to the content providers, because a lot of times, sometimes because of the problems within the network, and sometimes because how the network operates and how the OTT content performs might not be matching so well. So getting all of these data out would enable a lot of new value creation within the network. There are a lot of other aspects to the networks as well, like analytics, machine learning, and things like that. I mean, these are kind of the new hype. So machine learning, from our perspective, was always there in mobile networks. So SON is kind of one of the best examples of practical use of at least big data. So 5G is essentially going to be a completely, let's say, transformational network from that perspective. So I guess most of you would have seen this figure as well. So this is from the 5G PPP, where basically the operators tried to define what 5G could be about, mainly from a business case perspective. So traditionally, as I was saying, so 5G was mainly a B2C business where operators could sell SIM cards to the end customers, and they generate revenues from that, depending on how much calls they make or how much data they consume. But 5G is kind of a revolutionary network from a perspective that a lot of operators would have to evolve their business models, especially in terms of a mix of their business model, in terms of which parts of it comes from B2B and which parts of it come from B2C. So 5G is about factories of the future. So with ultra low latency and reliability, you can basically automate all the processes that are there in the factory wirelessly without the need of any of the wires, which actually contributes a significant amount of the capex that factories actually spend today. From automotive perspective, as we all know, self-driving cars is one of the biggest topics that is out there today. And with 5G, basically, all your algorithms that you would like to run on top of automated autonomous driving car, you can basically run it using 5G with extremely low latency and with the support of edge cloud. So basically, you could host your cloud applications on the base station with the help of edge cloud. There are a lot of media and entertainment applications as well. Like, so if you're an autonomous car, and if you don't have to drive, then you need to do something else, and media and entertainment is kind of the perfect use case for that. E-health, so we have already tried a lot of this, for example, in Finland. So if you go to the hospitals, a lot of their networks, I think almost all their network today runs on Wi-Fi. So if you actually look at the Wi-Fi networks there, you would see this ECG and I don't know what other machines there are. And this poses quite significant health and safety and security risk. 5G could provide a extremely secure network within the hospital. So one of my colleagues, so Nokia had actually a joint project with some of the operators in Finland, and they fully automated the children's hospital in Helsinki with Nokia's base stations. And my colleague was commenting that this was basically the most expensive small cell deployment maybe in the whole universe or something like that. So in terms of price, there is still something more that we need to do, but we are getting there. And the platform basically supports it. Media and entertainment, which is kind of the most interesting use case for a lot of people here. This is, as you know, 75% of the data that mobile networks run today is video. And basically, because of the, let's say, lack of interoperability between the media and entertainment community and the mobile network community, most of this data is completely unoptimized. So we believe that there is a lot of value that could be created jointly between the media and entertainment domain and the mobile network domain, because this trend of video over mobile networks is going to continue to increase, and there is a lot of let's say collaborative problem solving that could be done when the two industries come together. So a lot of times when I show this figure, people are confused, like, okay, you have shown me a lot of different industries that already exist today, and you say that all of this is 5G, but what do you really mean by that? So I try to explain what this really means. So what it basically means is that you have access. So basically 5G devices are capable of supporting all of these verticals. And anyone who wants to deploy any of these services has access to a unified 5G device layer, as well as a unified 5G network layer. So basically, with any device, 5G device that's available out there, you could put on an application and basically enable any of these verticals that are out there. And from a network layer perspective, it's completely transparent to what service is being hosted there, as long as you define what kind of SLAs would you need for the service. And the most kind of the interesting part is the application layer, where all the new 5G ecosystems could be hosted. I mean, as you know today, most of the value in the 4G is created in the application layer, which is then enabled by the network layer. This trend would continue in 5G as well. The only difference would be that the people who would like to deploy the applications would have access to a much wider range of devices than what is possible today. They would have access to a much wider range of features than what you would have access to today. You could have a lot of advanced proximity services that you could provide, secure access provisioning. As you know, 4G is one of the most secure networks that are deployed today. So there has never been, at least as far as I know, a publicly reported case of a 4G network being hacked. 5G is even more secure than 4G. So you have an extremely secure network. You have completely dynamic spectrum configuration. So 4G was mainly about the licensed spectrum access. 5G natively supports unlicensed. So basically, you don't need to license a spectrum to deploy a 5G network. You could just basically deploy it like as you do Wi-Fi networks today. But again, the difference would be that Wi-Fi does not provide you access to any of the quality of service that 5G would provide for you. Deploying applications is quite cheap, as everyone knows, as is the case today. You have completely new discovery and access mechanisms. So I always say that the traditional trust relationships that you have today with your carrier or network operator would be completely disrupted in 5G. And then this finally leads to new ecosystem collaboration. So not just in all the verticals that I've mentioned here, but there could be a lot more applications that we don't even foresee today. So the 5G as a platform provides you the flexibility to deploy whatever service you would like to deploy in future. So if it still sounds skeptical, so I put a source from IHS. So 5G is proposed to enable an economy of around $12 trillion of global economic activity by 2035. This mainly includes kind of the value shift that occurs when you have a completely automated factory. So basically the cost efficiencies that a lot of manufacturers derive today by moving it to, let's say, some other physical locations would essentially vanish in the 5G era. So basically you could have your manufacturing and production basically anywhere in the world. So this essentially creates a significant amount of value to the global economy, or it's proposed to do that. 4G already created a significant amount of value, and 5G is expected to accelerate that trend. Now, again, coming to a bit of the facts about 5G. So if there is someone here who doesn't know. So 5G is about new spectrum. So 4G was mainly about the below 6 gigahertz spectrum that was mainly used for the wide area communication. 5G is about a wide range of spectrum. It goes from the 300 megahertz, from the UHF band, to the millimeter wave. So there are even proposals of going up to 90 gigahertz around the world. There are a lot of auctions happening in different spectrum bands around the world. And 5G basically natively supports all of these frequency bands. So it provides you the flexibility to develop platforms which are kind of providing you access to a global ecosystem. 5G, from a physical layer perspective, is about beamforming. So as we all know, the traditional wireless networks or the wide area networks was mainly about providing wide area coverage. So basically you put up antennas in some relatively higher tall towers, and you would have large cell coverage areas. But when you move to this millimeter wave frequency bands, so this is no longer possible. And to provide this basic connectivity, for example, within this room, when you move to the millimeter wave frequency band, you need beamforming. So basically you need to group users into a much smaller set, and you need to then do the beamforming to enable basic connectivity. But the key advantage here is that it provides you a significantly high data rate, because there is a large amount of contiguous bandwidth that's available. 5G also supports 1 gigahertz of system bandwidth. So for 4G, it was up to 100 megahertz. So there is 10 times higher bandwidth that's available. There is a significant amount of flexibility that the system offers through slicing. So basically, an operator or anyone deploying the network could slice their network, and each of the slice could be defined based on different SLAs that you would like to satisfy. For example, if you take the case of this room, so a lot of people are accessing Wi-Fi for internet. I am talking still on the unlicensed frequency band for this PMSE type of application. So basically with 5G, you could have a micro operator network here, and basically slice and provide all the applications to all the users with some guaranteed quality of service. So all the speaker problems that we had in the morning, I'm sure that in 5G it's not going to be there. So not world peace, but still some more maybe quality of living. 5G is also about dual connectivity. So a lot of operators would like to kind of augment their network with 5G. So 4G and 5G would work quite well. I'll discuss a bit more about the architecture options in a bit. 5G is also about edge computing. It doesn't matter if the telco is actually deploying the edge or if it's some public cloud provider, but 5G basically provides you access to a cloud server, which is basically located locally along with your base station. And the base station, which is already available today, has quite good form factor to support the edge cloud as well. So if you really want these low latency applications, you really need the edge cloud. With open standards, you can develop applications that could be locally hosted in the edge cloud. So it provides you basically complete flexibility to deploy whatever service you would like to provide. So in terms of coverage, and this is basically for the traditional mobile network operators, 5G is going to be a combination of low and high frequency bands. So from if you're deploying a pure millimeter wave frequency band, it provides you 1,000 times higher local capacity than what's available with 2G. So based on some of the tests that we have done, so with 1 gigahertz system bandwidth, which is the maximum bandwidth, you could get 20 gigabits per second of speed on your smartphones or any of the other devices. If you're using 5G at 3.5 gigahertz with massive MIMO and LTE at 1.8 gigahertz, then you get approximately 10 times higher capacity than what you get today, with around average speeds of 2 gigabits per second, even with the same system bandwidth that you have in 4G, which is basically 100 megahertz. If you go still to the lower frequency bands, where if you have LTE 800 plus 5G 700 deployment, which could be, let's say, for IoT or critical communication, where coverage is quite important, you could still get 200 megabits per second with just 10 megahertz of bandwidth. So as you can imagine, so the capacity is getting significantly augmented. 5G provides the flexibility basically to everyone. So for the mobile network operators, they have the flexibility to basically augment the deployments that they have today and just put the 5G base stations to provide the additional capacity that the users would require. So what do I mean by dual connectivity? So I talk about a bit about some of the most popular architecture options that were defined in the release 15 of standards. So release 15 is basically the first specification for 5G. So option 3X is mainly popular with some of the operators who would like to just deploy the 5G base stations, but would like to maximally reuse the existing infrastructure. So EPC is the 4G core network. So basically, they could deploy the 4G core network and the 4G LTE Advanced Pro, which is kind of an advanced or software upgradable version of 4G to interwork with 5G. So basically, with minimal kind of OPEX investments, you could deploy 5G networks. It has much more advantages in terms of time to market, almost 6 months of advantage. And then it still reuses this LTE idle mode. So 5G has defined a new mode called RRC inactive, which basically minimizes the latency when the device goes into the idle mode, which most of the devices never go these days, if you really look at the network. It also provides the gain in terms of data rate aggregation between LTE and 5G and some of the data rates that I was mentioning before. So this is the non-standalone version. So it basically means that the 5G will never work without 4G. But there is a standalone version as well. Some of the operators are quite interested in kind of going full-blown into 5G and invest kind of maximum in terms of the OPEX or CAPEX. Standalone basically means that you have a 5G core along with the 5G G-Node B. So this is mainly useful for providing some new services. You could get significantly lower latencies. So from an end user perspective, they would notice that when they start browsing, they get the browse content much faster. If it's video, then the video you can see much faster than what's available today. But this is mainly applicable for the new verticals. So a lot of operators are actually already interested in targeting the new verticals, especially for factory automation and all that, where they could already start deploying these services for the new verticals. So for that, you really need the standalone 5G. You have a much lower setup time in 5G, so this was one of the key requirements from some of our customers as well, that deploying the networks were quite time consuming. But this has been significantly lowered in 5G, and it's going to go down more as time passes. Here, you don't need to upgrade the existing LTE network, but this also could mean that you have to spend more to operate two networks. So it depends on what kind of business model you have to deploy these services. It doesn't seem to work. Okay. 5G doesn't stop there. So then networks continue to evolve. So from an option 3 perspective, so if operators have deployed this option 3 where they basically augment 5G with their existing core network, moving forward, they have 2 options to upgrade their network. Both essentially involves the 5G core network, which again is purely a software upgrade. And then you have 2 options, basically option 4 where the control plane is in 5G. So basically you have an end-to-end 5G network with 5G core and the RAN, and the LTE would be controlled by the 5G network. So basically kind of the tables are inverted. Or there is the option 7 where the control plane would still go through LTE, and the 5G would be interworking with the LTE, or what we call evolved LTE. So as I said before, so 5G provides basically complete flexibility to the operators to deploy networks however they see fit. So now the key question is that, okay, all of this is quite good, but what's kind of the reality? Is it like, is the technology really being adopted, or is it going to be like 3G where there was quite significant hype, but the reality was quite different from the hype? So I've taken from the latest GSA report where about the countries where the operators are either demonstrating or testing or trialing 5G network, or they have licensed frequency bands to conduct field trials on 5G. And as you can see, the trend is basically pretty much all over the globe. So almost in all countries, all major countries around the world, operators have clearly declared their intent to deploy 5G, and not just declared their intent, but they have also started field trials, demonstrations, testing, and even in some cases, the first commercial network has been launched. I read a news report today that there has been maybe 7 operators now who said that they are the first to launch 5G. So I don't know how this works, but that's good news as well. In terms of the technology adoption plan, so around 67 telecom operators in 39 countries have announced their intentions of making 5G available to their customers between 2018 to 2022. So this is kind of the map of these deployments. And as you can see, North America is one of the first places where there has already been some launch with limited availability, along with other parts of the world. Sorry, I don't know if you see the small dot here, that's Finland, so it's there in Finland as well. And I don't know how many people know Nokia is a Finnish company, so of course 5G is there in Finland as well. All right, so now I move to the maybe the more interesting topic of the day, which is what does 5G really mean for broadcasters? And of course, there is always the question in the mind that, okay, there is already an existing digital terrestrial TV standards, which is ATSC 3.0, which already provides a lot of capabilities that 5G provides, especially from a broadcast perspective. So here I've tried to then still describe that, okay, why would 5G still make sense for broadcasters and for the media and entertainment community in general? So in a few words, if I were to summarize, the key reason or the key unique value proposition from 5G is basically a unified framework for common content delivery. So irrespective of what the common content is, to how many users you are sending that common content to, 5G provides you a platform to do that. And as I was saying before, 5G also provides you access to a massive amount of devices. From the last count, I hear that it's around 50 billion devices. So I wanted to explain a bit about the 5G-Xcast project as well. So it's a European Union funded project. One of the, to me, the main attractions for the project was that basically an end-to-end value chain from a media and entertainment perspective has been involved in the project. So from the academia, we had the University of Surrey, University of Valencia, which is the project manager, and then Turku University of Applied Sciences. From the content creation and production perspective, so we have BBC, EBU, and BT, who have been providing quite valuable insights from a content creation perspective. From a network perspective, so we have, for example, LiveView, Fair Spectrum, Broadpeak. Some of you may know some of these companies. From the network infrastructure perspective, so Nokia has been the main infrastructure player here, but we have also had Xway and One-to-Many who are quite active in the cellular broadcast topic as well. From the network operator perspective, we have Telecom Italia and British Telecom. And from the end user perspective, of course, Samsung is a consortium partner, and Xway, who are again involved in some limited capacity in the device industry as well, mainly from the middleware perspective. So the project has been going on for more than a year, and it will be ending in May or June next year. So one of the first vision that we defined as part of this project was the Convergence Vision. So we saw 5G-Xcast as a convergence of different worlds. As I was mentioning before, maybe those worlds were maybe not so much communicating before, but we hope that with 5G, you have basically a convergence of different worlds where everyone could work with each other to create significant amount of value, especially for the media and entertainment industry. So the Convergence Vision is mainly about delivering efficient media over fixed broadband, mobile broadband, and terrestrial broadband networks. So irrespective of the access network that is providing the connectivity to the end user, if you are kind of removing that complexity from the content provider perspective, this provides massive synergies for the industry in general, creating a significant amount of value. And hopefully the industry partners would be sharing this new value that's created. So from a 5G-Xcast vision perspective, so we decided to define a bold vision, which is again a unified content delivery framework, which is applicable for all the verticals. So in one of my earlier talks, I was showing that, for example, how 4G was defined was that for each of these verticals, there were completely different architecture that was defined, including a completely different interface towards the content provider. This brought in a significant amount of complexity, which basically also meant that most of these verticals never used any of these services. And this, again, led to what I call a lot of value shifts. So basically, when the networks get too complicated to operate, basically all the value shifts to the OTT. So basically, you remove or you kind of ignore all the complexity in the network by moving to a pure OTT kind of model. But 5G-Xcast vision is to provide a very simple network, a connectivity platform for all the verticals for media and entertainment, including very high challenging requirements in terms of UHD TV delivery, VR, AR, 360-degree video, content pre-positioning, and push-to-talk from automotive. So various autonomous driving information by regulation needs to be sent as broadcast, but these are quite geographically limited. There is a lot of infotainment information, safety application, signage information. All of this needs to be either multicasted or broadcasted. IoT requires also a significant amount of common content delivery, including common control messages and various updates. Public warning, as we all know, is one of the first use case of broadcast network. So the 5G-Xcast vision is basically to provide just one network architecture for all of these use cases. And if you remember the triangle that I had shown before, so when you actually go deep into some of these features, you understand that they are not as simple as you would think. So for example, when we were looking into VR into more detail, when you do VR unicast, it's much more simpler as compared to if you do VR broadcast. Because when you do VR broadcast, that basically means that you cannot do any field of view optimizations. So basically, you need to broadcast a huge amount of content to a large number of audience. and this content is then highly contextual as well. So broadcast is usually limited by the amount of content that could be sent over the air. So we have looked at a lot of optimizations that could be done here as well. And since 5G natively supports unlicensed spectrum, so this has been another key innovation that we have been working on as well. So for example, if you do multicast or broadcast over Wi-Fi, this is never efficient because you always need to use the worst MCS. So with 5G, which natively supports unlicensed, you can get significantly high data rates with broadcast, which basically you cannot get with most of the other access technologies that are available today. So when we went deeper into these requirements, we realized that actually 5G-Xcast kind of converges all the three boundaries as well. Because if you take VR as an example, you need extremely high data rates. So if you look at the fully immersive VR, it really goes into a few gigabits per second in terms of data rate. You need to support a large number of devices. Depending on what kind of use cases you are looking at, it could be some few hundred devices that you might need to support. And you need ultra reliability or at least low latency. So whenever the user is changing their field of view or kind of changing the content that they're viewing, the content should be extremely responsive. So this brings in a lot of challenges that was not kind of foreseen when the researchers were looking at the unicast networks. So we also decided to apply a lot of design thinking. So maybe one question you might have, if you know the history in mobile networks, is that this is not the first time people have tried to define broadcast using mobile network standards. I think the first attempt was around 20 years ago, and it has never succeeded. So we really decided to apply some design thinking to understand why this has been happening. And one thing that we realized was that the traditional standards that were developed from the mobile network community for broadcast has been kind of in between the two worlds. So it was not good enough for the digital terrestrial TV standard perspective. So in terms of spectral efficiency, coverage, the transmit power requirements, and things like that, it was never good enough as compared to the state-of-the-art DTT standards. And it was never good enough for the mobile network industry as well, because the standards were in the end so complicated, putting in a lot of requirements for the devices who basically don't get any benefits out of that, basically neither the mobile network industry nor the broadcast industry adopted the standard. So this has been kind of going on since 20 years. And we decided that, okay, if we try the same thing again in 5G, the result is going to be the same. So we tried to split the story a bit into two. So we realized that you need to define basically two different sets of standards. One for the terrestrial broadcast mode, which is mainly aimed at high power, high tower, very high coverage area with downlink only connectivity, with some possibilities to set up local, regional, and nationwide single frequency networks. The other mode would be this multicast mixed mode, where basically you can seamlessly switch between unicast, multicast, and broadcast with feedback from the devices and with very high commonality with unicast. So personally, my bit favorite mode is the mixed mode, because it's basically almost, it could work almost the same as how unicast works today. So if the broadcast community really adopts that, that basically means that they really have access to all the devices without basically any additional implementation that would be required to support broadcast. But this also means that the coverage area might not be as much as you would see today. But the terrestrial broadcast mode would have this kind of a coverage area, but it always imposes quite a lot of limitations on the physical layer, which basically means that you need some special implementation. So the access to devices would be then, depending on how the ecosystem plays out and how kind of the value proposition and what kind of interesting business cases could be built on top of this. So we decided to split the story a bit into these two parts. And actually, we went ahead and defined the end-to-end system architecture as well. Sorry, okay. Basically, nothing is readable here, but hopefully when you see the slides, which would be shared here, as well as in the 5G-Xcast website, you can see that basically we have reused the 5G service-based architecture, but tried to define two different modes, where one is kind of the LT evolution mode, which supports the terrestrial broadcast, where you need some kind of special functions to support broadcast. And the other is the 5G unicast evolution, which is kind of the transparent mode, where basically you almost have no impact to the 5G unicast network. So basically you take a release 15 base station, do some small software upgrades, and you get access to all the 5G devices starting from the first release. So these are kind of the two architectures that we defined, and kind of the main difference here has been because of the limitations that is imposed by the terrestrial broadcast mode. And one of the key limitations, of course, is the support for idle mode devices. So basically, one of the key requirements that comes from the broadcast community has been that they need to support idle mode devices, which are basically devices that are not registered with the network. And this is not possible, especially if you have high power, high tower. So getting this uplink with the devices, which could be TV or any type of device, smartphone, even smartphones, it's not possible. But with the transparent mode, because it supports only the connected mode and the inactive mode, basically you can reuse the unicast mode for that. With the inactive mode, you also get significant energy saving benefits. So it basically works the same way as the idle mode, but the device is registered with the network. And kind of, if you really think about it, the advantage with that would also be that you really get all the data that you could collect from the devices if it's registered with the network, because you get basically per user information in terms of how responsive the user was and how did they consume the content. This has been a research project, but we have also been focusing on trying to bring this into reality. So we actually heavily lobbied for 3GPP study item, which basically is the first step to get some specification done. So a lot of the partners in the project got together, and we actually got a release 16 study item accepted. It's called LTE-based 5G terrestrial mode. The title is quite confusing. I don't know what would be the conclusion of that. It literally says 4G-based 5G broadcast. But well, 3GPP is a complex world, so you need to accept what you could get out of that. And interestingly, that study is starting today. This month, or maybe already this week. And for example, BBC and EBU is heavily contributing there, along with a lot of the other partners from the project. Usually, study item is the phase where you study a problem, and work item is the phase where the problem is kind of solved in terms of the specification updates and all that. I've put some of the deliverables that we have worked on, which would be contributed to these studies as well. I'll later on show a link where all of these documents are available or would be available. We are also planning to have a release 17 study item and work item, hopefully in Q4 2019 or in the 2020 time frame, which would be mainly targeting this mixed multicast mode. So we are really pushing for this topic to not just stay in a vision and in a lot of different deliverables, but to go to reality as well. And personally, from Nokia's perspective, since we always follow the standards to implement products, we really need those standards ready to kind of get this implemented in our products as well. So I had said in the beginning that I'll try to kind of summarize what kind of value proposition is 5G offering for you. So if you're a mobile network operator or a broadcast network operator, what 5G provides for you is a simple and efficient transport network with reduced transport network load. So it provides you all the efficiencies that you would get from a broadcast network, with minimal total cost of ownership. So you basically have to spend very limited amount of money to own that kind of a network. 5G-Xcast also leverages OTT innovations and ecosystem partnerships, which basically means that so a lot of content providers today follow what I call kind of a multi-channel strategy. So basically, the content is available from a lot of different channels, whether it's a broadcast network or if it's whether it's through a streaming website or through any other source. So 5G-Xcast is fully OTT compliant. So basically, mobile network operators or broadcast network operators could deploy a simple and efficient network with this unified platform and get access to this wide range of devices. There are novel collaborations that are possible with the content providers for advertisements or new revenue streams, efficient transport of what I call elephant pipes, especially if you are talking about virtual or augmented reality. What I mean basically here is that with all the network exposure functions that are available in 5G, basically you could have new partnerships with the content providers and essentially enable new revenue streams if that's kind of the business model that you operate in. And in the US, this is actually quite visibly seen already. You could also have AR and VR deployments if you would like. And as I was saying before, broadcast brings in a lot of different challenges. And if you have experienced VR broadcast today, you would realize that the quality of experience is much further away than optimal. With 5G, you would get all of these efficiencies. From content provider perspective, what do they gain? So basically, they would get controllable quality of experience. So there was an excellent talk today morning about all the big data analytics you could do to get better quality of experience. And basically, again, when you expose all of these data to the content providers, basically they have access to all of this information in terms of what kind of quality of experience are the end users getting. With the flexibility of 5G, you could have a lot of new slicing options where the content providers could dynamically redefine what kind of SLAs they are receiving with the broadcast network or mobile network operators in real time. This was never possible in the previous generations. And we have also been looking at how do you do this kind of automated or dynamic network slicing. How do you kind of build dynamic trust relationships with a lot of the content providers? So, I mean, if you're especially looking at the OTT content, I mean, they have basically a global scale, and most of the network operators usually have a geographically limited or kind of a physical scale. So operators could leverage still their physical scale and try to capture some of the value that OTTs are capturing today by efficiently using the flexibility that 5G provides. 5G also provides an access to a massive and global end-to-end 5G ecosystem. So basically, content providers have access to, as I was saying and repeating a lot of times, 50 billion devices, which uses a multitude of different, supports a multitude of different use cases. So this kind of enables a completely different economy of scale than what is available for the content providers today. From the device vendor perspective, so multicast broadcast is basically, let's say, not a strong value proposition for the devices, because basically in the end, from a device vendor perspective, their users can watch a video, which they can do already today. So we need to kind of de-risk multicast broadcast for the device vendor. So this is kind of our key learning here. So we need to minimize the complexity for the devices. So if you say that, okay, you need to have some special receivers or very high complexity implementation in the device or a lot of testing complexity, this is never going to succeed. And this is based on our experience during the last 20 years in the previous generations as well. And as you can see, even in the device industry, there is quite significant value shift that's happening. And if you really would like to achieve the scale, you really need to de-risk the complexity for the device vendors. And especially with this mixed mode, it's possible today. So basically, device vendors, one of the key advantage for most of the device vendors is that if they buy a chipset from Qualcomm or MediaTek or someone else for unicast, they basically don't have to invest any additional OPEX, because basically the chipset vendors do all the testing. But when you have to support multicast broadcast, this is some optimization that the device vendors today need to do per market, which brings in a lot of OPEX expenses for them, which is not a value proposition today. So we really need to kind of de-risk this. And minimizing the complexity also provides access to a wider range of devices. So if it's basically working the same way as Unicast does today, basically all the you get access to all the devices, irrespective of whether it's a TV or a mobile device or even a VR headset. This also enables the deployment of new use cases and features with minimal added cost. So basically, the cost that you would have to deploy new services would be almost zero. And as I was saying before, why the ecosystem or the over-the-top ecosystem has been growing so rapidly in 4G was basically because of this, that basically if you want to deploy a new app to provide some new content to the end user, you didn't have any of the complexity from a device perspective. So the only added cost that you had was to develop the application. Now, I promised that we talk a little bit about some of the 5G myths or fiction as well. So one of the let's say, first myth was, does 5G help you fly? Well, unfortunately, 5G does not help you fly. But 5G does let you control drones all over the world with very high reliability with these swarm of drones. So I don't know, maybe drones could help you fly. Another myth, 5G will enable teleportation. Again, this is also a myth or fiction, so 5G is not going to enable teleportation. But if you really see how fast the data rates are growing, so this is maybe something for 6G to do. And now finally, can 5G solve all of the world's problem and bring world peace for all of us? So, maybe a small piece of the puzzle will be provided by 5G, which is basically a fully connected world. And this reminded me of a personal experience that I had. So one of the first business trips that I had, and which took me outside India as well, was when I was going to Rwanda, to Kigali, where we were deploying a wide-scale mobile network there. So I think in the Western world, traditionally, access to information has been quite easy, and it has been getting much more easier. But if you really see the value that is being created and kind of the significant amount of value that's being added is from different parts of the world which are getting connected. So the immense amount of information, even with 4G, which is accessible to different parts of the world is quite amazing. And with 5G and with all the use cases that you could have, it's going to be even more amazing. So imagine remote surgery, where a surgeon who is highly skilled and highly trained in one of the best university in the US, imagine them doing a surgery for patients who are in India or Africa. So this is going to enable create amazing amounts of value, and it's also going to bring a lot of amount of information to all the users around the world as well. So yeah, thank you. This has been mainly my talk. So I've put some links here if you would like to get access to some more of these documents and some of our social media outreach mainly from the 5G-Xcast project. And finally, thank you for listening to the presentation.